So what I'm going to do today is talk about preventive maintenance. And what happens with our preventive maintenance systems is it kind of becomes a repository. It's sort of like your junk drawer at work. Everything goes in and nothing ever comes out. And when you need that Phillips screwdriver, you open up the drawer and you find the thing that, wow, what was this? Or, you know, the squirt gun that you confiscated from grandma's in there, but you don't find what you need. And that's the same thing with our PM programs, is we just keep shoving stuff in, and never really evaluate it. So I'm going to give you some techniques on how to evaluate it. So you guys, if I do my job right, are going to come out of here with some homework. So if you want to go now, go ahead. But so that's what we're going to talk about today. So first I want to set some ground rules, talk a little bit about what definitions I'm using. The term PM is used over and over for a lot of different things. So for this talk, what I'm going to be talking about preventive maintenance is the routine maintenance. So whether it's time-based maintenance, whether it's condition-based maintenance, whether it's tool maintenance or sensory maintenance, anything that's done on a routine basis, whether it's hours or time, you know, all that routine stuff, that's what I'm talking about for PM. Criticality. Criticality goes with PM because what we do with criticality is what we use to assign resources. So if we're going to clean up that PM system or build it if it's a new one, we need to assign resources. How do we assign resources? By the most critical equipment. So it's really about allocating assets. Now most of us, when we think about criticality, we think about ABC, you know, 1, 3, 7, something like that. You have somewhere between a 3 and usually 5, maybe a 7 criteria, which works awesome if you're using it for a rhyme system where you're taking the criticality of the equipment, the urgency of the work order, multiplying them together, and figuring out what work order to work on. When we're talking about criticality here, as you can see, I say the resolution should go to the square root of the data set. So if you've got 10,000 assets, that means that your criticality should be 1 through 100. It actually doesn't take any more time to do that than to do the ABC criticality. Now, I'm not saying throw this into your CMMS, but have that criticality available so when you start allocating assets like a PM review, you can actually say what's your top 10%, what's your top 5% of equipment. If you've just got an ABC indicator, you've got things lumped into too big a categories to try and tackle them. You need to you know, take that elephant one bite at a time. And by having a criticality system with this much resolution in it, you can actually assign those resources. It's no longer too big to handle. And you can still use that and then translate it into an ABC system. So if you've got something that's, you know, 1 to 100, your top 20% are your A's, your next 30% are your B's, and your bottom 50% are your C's. So it's no more work to do granularity to this level, but it gives you an awful lot of energy to then assign resources and allocate your resources later on. So the Ida P2f Curve. How many people have seen this before? Either the rest of you are just too tired to raise your hand, or I'm blowing you away with 100-year-old technology. So the installation to P, potential failure, I call it defect. That installation to defect, that is actually not a maintenance function. Maintenance cannot affect that. That is a design, purchasing, and installation. Now, if your maintenance department does your installation, they obviously affect that. But that's outside of the maintenance area. That's really the engineering people that should be responsible for that. And that's really your MTBF curve. What we should be saying when we get a new piece of equipment in, when we get a new installation, is ask the engineering department, what is its life cycle?